A horizontal line this time, right. So you have the same arc you had before. My axis is drawn very poorly. You have the same arc like this. Where does it hit the y-axis? 9, right. It's y equals negative x squared plus 9. So you have 9 right there. And you're looking for a horizontal line that breaks that region into two equal pieces. In 1a, you found out the whole thing. What was the area of the whole thing? The whole area was 18. So what's half of it going to be? 9. So you know the whole thing is 18. So when you draw this line, I mean, you can approximate. It's not going to be halfway because it's wider at the base. So let's say it's right about there. Again, this is not to scale. That's y equals h. Let's call this region 1 and this one region 2. What is the area of each of those regions going to be? Yeah, you know region 1 is going to be region 2 because you want them to be equal, and they're going to equal 9. What I'd like you to do now, take your head and tilt it 90 degrees to the right. What you're going to do is you're going to set up an integral just 90 degrees to the right. You're going to do it in terms of y instead of x. You're going to do it in terms of y instead of x. So what is this? That's 0. This is h. So it goes from 0 to h to 9. It goes from 0 to h to 9. Region 1 goes from h to 9. Region 2 goes from 0 to h. So what you're going to do is you're going to have a region. So region 2 is going to be the integral from 0 to h. You're not doing it with respect to y, you're doing it with respect to, sorry, you're not doing it with respect to x, you're doing it with respect to y. And you know that this integral is going to equal what? Because it's half of the overall. It's going to equal 9. But here's the tricky part. You're integrating with respect to y because each of these rectangles, you remember adding up all those rectangles, kids? You've added up rectangles before? Yeah, maybe, kind of, sort of. The little tiny piece right here, this little distance right there, that little distance right there, is that a piece of the x-axis or the y-axis? This little piece, that's a piece of the x-axis. You're integrating with respect to y. What? This is a piece of the y-axis.
Yeah, you said x.
Oh, I'm sorry, yes. It's a piece of the y-axis, dy. So the height, if you're integrating with respect to y, whatever you plug in here needs to be in terms of y. If you have dx, it's x. If you have dy, it has to be y. So the question is, if this right here is dy, you need the height. How do you figure out this distance right there? How do you figure out that distance? Solve for x. Yeah, Tina, very good. You know that y is equal to negative x squared plus 9, correct? What can you solve for now? You can solve for x. So what do you have? You have x squared is equal to 9 minus y. So x is equal to plus or minus the square root of 9 minus y. So that's two of them. It's plus and minus. The positive x values and the negative x values. Which ones do we want? The positive x values or the negative x values? We want the positive x values. So which one are we going to take? We're going to take x is equal to the square root of 9 minus y. And where are we going to put that? Right there. The square root of 9 minus y. So what are you solving? You have the integral from 0 to h of 9 minus y to the 1/2 dy. And what is that going to be equal to? 9. It's going to be equal to 9 because it's half of the 18 that you found in part A. So what you have to do now is you solve this. You integrate and you try to solve. So that's what I'd like you to try to do now. The equation is right there, 0 to h. Please solve. Okay, so what power do you know the integral has to be to? 3 over 2. You know it has to be 9 minus y to the 3 over 2, which means what do you have to put in front? 2 over 3. And there's a negative right here, so what do you have to put on the outside? A negative 1. Because you have to take care of that because of the chain rule. And you know that this evaluated from 0 to h has to equal 9. Exactly. So now you have to actually evaluate it. So you have negative 2/3 9 minus h to the 3/2 minus 2/3 times 9 to the 3/2. And what's that going to equal? That equals 9. What is 9 to the 3/2? Oh, it's going to be plus, isn't it? Thank you. It's going to be plus because, look, there's a negative and you're subtracting. So what is 9 to the 3 halves? 27. So you have negative 2/3. 9 minus h to the 3 halves plus 2/3 of 27 equals 9. 18. So you have negative 2/3 of 9 minus h to the 3 halves equals negative 9. So then you make both sides positive. Multiply by 3/2 and you end up with 9 minus h to the 3 halves is equal to what? What's it equal to? 27 over what? 2. And then what do you have to do to both sides to this to isolate? If we're going to isolate h, 9 minus h is equal to the power of 2/3. Thank you, Thomas. Yes, exactly. So therefore you know that negative h is equal to 27 over 2 to the 2/3 minus 9. So what does h equal? 9 minus 27 over 2 to the what? 2/3. On a test, this is where I'd like you to get to right here. But if you wanted decimal places, to 3 decimal places, fun, 3.330 would be the answer. It goes on a little bit, 3.55275. Is that about what it should be? Does that look like a realistic answer? It does look like a realistic answer, considering, what's halfway between 0 and 9? 4.5. Do we expect it to be below 4.5 or above? Because it's wider at the bottom, so it should be below. So that this matches reality. This is a little challenging. Plus what? 100. 100t. Plus what? E. But we know when we plug in 0 for t, what does it equal? So we know that 0 is equal to 0 plus e. So what does e have to be? You know that e has to be 0. So if we plug that into our equation up there, what do we end up with? We end up with s of t is equal to c over 2t squared plus 100t. So we've used this, but what is s of t? This is the last thing. We haven't used that right there. When you plug in ts into the position function, what should you get out? 80. So 80 is equal to what? C over 2 ts squared plus 100 times what? Ts. Look what you now have. Here's one equation and here's a second equation. You have 2 equations. How many variables are in there? 2. If you have 2 equations and 2 variables, what should you theoretically be able to solve for? Each of them, because you'll get one, and then with one you can get the other. So try to do me a favor, find TS for me. Find time stop. How many of you know what the fundamental theorem of calculus is? Would you consider the fundamental theorem of calculus to be something that's important? Yes. What's the giveaway that it's an important theorem? Yes, and what's the first word? Yes. Are fundamental things generally important? Yeah. So it is important. Is it important that you know what this theorem states? Yes, it's very, very important.